Oh, hey everybody. Ooh, that's loud. I haven't done one of these talks holding a mic for a long time, so we'll see how this goes. Cool. So welcome to an introduction to GraphQL and .NET Core. One of the reasons I wanted to give this talk a while back was that most of the GraphQL sort of intro sessions I've seen have been all sort of JavaScript fashioned. So they're all Node.js, TypeScript, JavaScript on the server as well as the client. And there's actually a sort of a rich ecosystem of sort of GraphQL in .NET. So but not as many tutorials around it. So let's sort of dig into that. So what are we going to cover? Basically, to begin with, some sort of GraphQL basics for people who aren't as familiar with it. So what is it? Why would you want to use it? The benefits, etc. We'll dig into like the actual nuts and bolts of building a GraphQL server in .NET Core. And then we'll sort of go through a bit of a whirlwind tour of some of the advanced features and what you can kind of do with it sort of long term. So who am I? My name is Nigel Sampson. I'm a staff engineer here at PushPay. Thankfully, Marcus has already said we're hiring, so I don't need to repeat it. But yep, if any of this stuff interests you, come have a chat with me. So let's go jump into the basics. So what is GraphQL? The general gist is that it's, as it says here, a strongly typed specification for querying data from a service. So one of the things that's really interesting here is it's strongly typed. It's not sort of loosey-goosey. You get kind of integers are always integers, strings are always strings, and it's about getting data from a service. What I haven't said here is HTTP or JSON or anything like that. So what's really interesting is the GraphQL spec doesn't mention HTTP almost at all, right? So you can actually call GraphQL via, I've seen implementations using things like gRPC and so on, but 99% of the time it's going to be about JSON and HTTP. So it's originally from Facebook. Facebook built this as an internal tool and then released it as a specification. So there is an official GraphQL spec, which more companies than Facebook now participate in. And they released a sort of a reference library. So they wrote a GraphQL JS library, which implements the spec. And then other companies have gone from there and built libraries on top of that. Probably the main one you'll see is Apollo. So Apollo GraphQL, sort of JavaScript node based as well. And then you'll find sort of implementations of that specification in other open source languages, or almost all languages really. So you'll be able to find a GraphQL Ruby library, a .NET library, a Rust library, and so on. But ultimately, they're all sort of adhering to this Facebook spec. So another interesting thing is, which we'll go into as well, it supports API introspection. What this means is you can ask the API about the API, which is really useful. So you can sort of query the API and say, hey, what are my capabilities? What can I query? What sort of data can you give me? And we'll go into why that's really cool in a minute. So let's see. We'll go through a few quick demos. Cool. So we can still see that all right? Still see, no, never mind. Cool. Okay, so this is a tool called Insomnia. It's basically a normal sort of REST style tool. We've seen things with Postman, etc. We're building requests, we're sending requests, we can set headers and so on. The good thing about this one is it supports GraphQL out of the box, so yay. So the example I'm going to work through here is one called for sort of posts, and we'll start with the front page, right? So let's say we want to build a blog, we're querying the front page, so I want to query posts. So here on the left here is what I'm sending to the server. So a GraphQL query is always a post. I'm posting this query. I'm posting this information on the left, and I'm getting back the information on the right. So to start with, I'm saying this is a query. Cool. And I'm asking for posts. Within that posts, I'm asking for the title, the ID. I'm going to need that if I want to link to another post, the title of the post, when it's published, the image, and the author. All the things you kind of think of when you want to actually get back the data. And we'll start the server up. So if I send that, you can see here that the data on the right matches the data on the fields I'm requesting on the left, in the sense that, data, posts, ID, and we see the structure on the right. mimic the structure on the left. What's interesting here is I can change my query. I can say, I don't want title. And now my data on the right, I don't get title back. And Insomnia, see, that's not zoomed, but has IntelliSense. So it can show me what are my available fields that are available on this post. You know, there's other things in here like comments, the HTML, the markdown, and so on. But I'm not requesting them, so I don't get that data back here. Imagine then we click through on the post, and we actually want to view a post itself. So here's another GraphQL query. So we're doing a couple of interesting things here. This top post part here, this is a field called post, which takes an argument called ID. So fields in GraphQL can have arguments. There's no real difference between a field with 0 arguments, like title or author, or a field with 1 or more arguments. They're still called fields in GraphQL. There's no difference, like there's no methods versus properties. They're all just fields. In this case, it's one called ID. We want the ID basically give me a single post, not a list of posts now, but give me a single post. And at the top here, I'm basically passing what's called a variable. So I've created a variable called dollar post ID. So all variables in GraphQL start with $. And up here is actually where that variable has been declared. So I'm saying there is a variable called post ID, dollar post ID. It's of type ID, which we'll get into later. And here's where I'm using it. So clear the variable, use it, basically passing into this argument. And down the bottom here, if you can see it from the back, is essentially a little bit of JSON, which is declaring the values for those variables. Why that's really important is it means that the content, this query at the top there, is essentially static, right? The things that are differing when I go between different posts in my application is just the variable data down the bottom. The post stays the same. If you imagine that I changed this to like actually use the ID up here and didn't use that variable, then it would mean that anytime I wanted to build a different query, I'm sort of having to build this query sort of on an ad hoc basis. And I'm not sure if GraphQL injection is a thing, but it possibly could be, right? So just the way you wouldn't build up a SQL query using string concatenation for all the security nightmares that come along with that, you probably don't want to do that with GraphQL either. So using variables like this is a way to sort of static part of the query, variable part of the query. And you can see down here also that we're using another argument on this this image field. We're saying give me the size, where size is actually an enum of small, medium, large, and so on. And again, same thing, the data on the right supports the data on the left. Same shape, just different shape in this regard. And then the next thing is something called mutations. So mutations are essentially the opposite of queries. I'm running a request now that it's going to be changing state. So it looks exactly the same as a query, except for the top part, which is the mutation instead of query. And realistically, it's only this top field, the submit post, which is the mutation. This is the thing that changes the state. All the fields below that are ultimately just essentially a query on the result of that mutation. So if you think about like when I submit a post, the result of that is going to be a post. And so I'm querying information about that post that I just submitted. So you can see here again, I'm using a variable called input of type submit post input. And this actually has a bit more structure. So this is I've created a sort of a rich object, which is saying this is the thing I want you to submit. So this is, as I said, it's type safe. I'm creating a type called submit post input, which we'll get into later. And it has these fields, author ID, the title, the markdown. And as you can see, we post that, we get back the post, and we can query those fields off that post. It all makes sense. So like the important parts here are that we are posting a query to the server and we're getting back data. And we can customize what fields we get back in that response based on the query we send. And there's some sort of advanced features from there we'll go get into. That's the basics. So clients can should only select the fields they require. Keep sitting down, it's nice. For their use cases, right? So there's no way in GraphQL to do the equivalent of select star. You can't say, give me all the fields on this type. You have to say, these are the fields I want. And that's really important for a number of reasons. And this means that you can very easily tailor the size of that response to exactly what your application needs. And going back for a second, one thing I didn't quite show there is that we're sort of like it's GraphQL graphs. We're traversing nodes here, so in the sense that this list of posts like has an image object which has a URL child, different fields, an author has a name, and it has, I don't know what other fields I've got on here, an ID and a name, etc. So like this is how we've got this notion of a graph and transiting between things. Let's bring that up. Cool. So why is being able to, being forced to specify exactly what fields you want actually important? So this is where this notion of sort of under and over selection comes in. So if we think about how you might build a blog API using REST, right? Let's say we had an endpoint where you would get all the posts down, or you'd call it like /posts. You'd get back the JSON which had all the post data, the ID, the HTML, the markdown, the author ID. This is the notion of over selection. If I was building just the front page of my blog and I called /posts, I'm getting a huge amount of data I don't care about. If I'm getting the markdown plus the HTML and all I wanted to do was display the title, I'm getting a lot more data on the wire than I actually cared about using. At the same time, I didn't get all the data I cared about using. If I want to put the author name in there, chances are that response is going to have the author ID in it. And then I'm going to have to go to like /authors /42 or whatever to get, the author with ID 42, get their name and so on. So this is the notion of under selection is, hey, I'm making this request and I'm not getting all the data I care about. Or when I do a request, I'm getting more of the data than I care about, which is really important when we get to things like mobile apps. If we're building a mobile app or anything like that, where your user is on a 3G connection in Invercargill, the amount of data on the wire is really important. And the fact that you can do it all in one request is even better because you're saving the person's battery and their bandwidth and all sorts of reasons, all sorts of things, which is really good. I mean, if you get into things like building REST APIs, you can, like a lot of people solve some of these problems with things like denormalization. So on that posts endpoint, you might have like the author name and the author ID because there's a good chance that everyone who wants the author is always going to want the author name. But then you're customizing for one scenario. You're tweaking your API and sort of breaking REST just to solve one scenario when the next scenario might need the author's age or something like that. What GraphQL supports or really helps you with is that you're always getting data, exact data you want for your scenario in one request. Make sense? Cool. So, So why is API, why is not having the ability to go select star a good thing? Well, first thing is it means you can't do over selection. You can't do the notion of making a request and getting all the data and wasting person's bandwidth. But it also means that for me building the server, if you're forced to only ask for the fields that you care about, it means that on the server, I can know what the fields are that you care about. A really good example of that is for when you want to do sort of API migrations or like making some sort of breaking change to your API. So a good example might be, let's say I have a customer object or customer person in my API, and they have a shipping address. And then later on, I want to support the notion of having multiple shipping addresses. And therefore, I need to get rid of that shipping address field on my customer. Well, like if I'm building a REST API, I have no idea who's actually using that shipping address. I can issue an API advisory to say, in 3 months' time, I'm going to remove shipping address. And if you haven't fixed your code by then, tough. It's your problem. What we can do with GraphQL, though, is say we can introduce our shipping addresses field. We can leave shipping address there, mark it as deprecated in some way, and we can measure on the server who is still asking for shipping address. Because we know if the people who are interested in shipping address have to send it in their query, and therefore on the server we can measure who's still asking for it. As if we've got some interesting API logs, we're correlating requests with customers, we can potentially even call them up and say, hey, we've given you the 3-month warning. we notice you're still using shipping address, then you can provide a bit more feedback. So you can actually measure on a field by field basis who's using what fields, who's using what parts of your API, right down to that field level as opposed to just like the request level. Cool? Makes sense? Sweet. Sweet. So let's get into it a bit more. So a GraphQL server made of two parts, schema and resolver. So a schema is the definition of the graph. It's the types, the fields, and it's essentially what's available to you. The resolver is how you go and get that data. So the first thing is, let's dig into the schema. The GraphQL schema looks a bit like this. So this is a request. I'm requesting from that endpoint. I'm going to a slash GraphQL schema, and I'm getting back this. This is called the SDL, or the schema definition language. So it's part of the Facebook spec, and it's a way to describe a Facebook schema in pretty human readable terms. So often when people are sort of sending discussions about like potential schemas, or like if you're looking up on schema documentation, you might see something like this, because it's a pretty easy to, in my opinion, this is reasonably easy to read. Hope you all agree. I'm looking at an author here, type author, they have an ID, they have a name, they have types. We'll get into some of the more detail in a minute. The other way you can look at a schema is by something called the introspection query. So as I said before, GraphQL supports this notion of introspection, which means you can ask it about itself. In this case, I'm actually sending a GraphQL query to the server and getting back information about the schema. So in this case, you can see this query here. I'm querying the schema. I'm saying, give me the types that are in this schema, give me their names, give me the fields on those types, and give me the names of those fields. So if we dig down, and if you look here, interesting enough, like it'll actually give you information about the type information of the schema. So you can get type information about querying this, which is introspection on top of introspection, kind of fun. But the important part here is if we find one that we care about. Here we go. Right, so we have a type called comment. It has the ID name that's submitted on text. So this is useful as well. Like, we're doing an introspection query and we're getting data back in JSON. Why is that cool? Because tooling really loves to read JSON. If you were wanting to write some sort of tooling support into your app or anything that you're building that wanted to support GraphQL in some way, like having to write code that parsed this SDL would be a pain. But we all have built-in libraries that can kind of parse JSON. So if we think about like the way this tool here, Insomnia, is letting us do IntelliSense about what fields are available, what you can think about under the covers is that Insomnia is doing an introspection query like this to my server and saying, hey, what are the fields available? So it's driving IntelliSense based off these introspection queries. Cool? Sweet. So let's get into the SDL a bit more and see what we can actually do. So we have the basics of GraphQL there are types. What we often think about as objects. These objects have fields. These fields can be what we call scalars, simple types, string, boolean, integer, all the things we think about as sort of simple ones. ID is also a basic scalar type in GraphQL, or they can be objects. Ooh, my bad. So in this case, product has a thumbnail. Thumbnail is an image. Image is just another type with its own fields. GraphQL supports the notion of lists. So a product with those square brackets. So a product has a list of reviews. Makes sense. And the exclamation mark there is this notion of non-nullability, right? So in this case, a thumbnail, we don't have the exclamation mark. So a product might have a null thumbnail, but it will always have an ID and it will always have a name. The double bang in the reviews is kind of fun here. What that means is product will have a non-null list of non-null reviews, which is fun to think about. But what that essentially means is that product will always have a list of reviews. It might be empty, but it'll never be null. And the things that will be in the list will always be not null. even, which is kind of fun to think about. But what it means is you're not likely to have review, review, null, review, review, which is kind of a weird thing to have in a list, but like the API supports it anyway. That makes sense. We have types, we build a graph from there, and some more advanced stuff. So we talked about this idea of arguments. So we're creating a type called query. Because it's a graph has to have a root, and often that root is referred to as being the query type. Most libraries call it the query type, but we'll call it, it can be actually arbitrarily named anything you want. In this case, I'm creating two fields on top of that root, one called products, which returns, again, a non-null list of non-null products, and another field which takes that ID argument and returns product. In this case, you probably want to make it nullable, because what happens if it's an ID that doesn't exist? You want to be able to return null for that. And the last part there is a little bit basically declaring that this type query is the root type. So it's basically saying for queries, the root type of that query is this query type. And we can go from there. Next part we can declare is something called input types. So input types are the things you might send as arguments to mutations, or arguments to just regular fields. So if we look back here, that product ID takes an ID type, but that's a simple ID scalar, but we could declare our field as taking a more complex argument, which is something that looks like this. So add review input, pass in a product ID as well as context or a string at that point, and we can declare our mutation, add review, and it takes an input of add review input. So this is where we're using our strong types again. And so what this means is GraphQL can actually enforce a lot of this stuff at the server level. It'll tell you off without your code even having to do anything wrong. So if I go back to the demo here, back to my query, if I try and a field that doesn't exist, so let's query for Marcus as a field, it's going to tell you off. Like GraphQL server will say back, hey, this Marcus doesn't exist on post, go away. And the good thing about that is, like, the library, your server implementation is going to handle that for you. You don't have to worry about that. Same thing with the inputs. It'll tell you off if I take rid of this, saying, hey, you're not, it's just ignored it, but it's actually invalid GraphQL. So it's in this case, it's saying no. I'm surprised that works, to be honest. And again, if we go back to our submit, yeah, that would definitely fail. If I just basically ask for the author, like, that's going to complain because, hey, author's an object. You can't just select the object. You have to select the leaves, because select star isn't a thing. And if we go to submit post, and I do something like put another field on here, that worked, but it's probably ignored. But we get some IntelliSense down here going, hey, that's not an actual thing. Cool. So, where were we? Let's get into building something. So I'm using a library here called Hot Chocolate. There's a number of GraphQL libraries in .NET Core. The one that you'll probably find the easiest is one called GraphQL.net, because it definitely got the best name, the easiest to find name. Here at PushPay, we've used GraphQL.net as well as Hot Chocolate. Personally, I prefer Hot Chocolate. We've got a number of microservices using GraphQL.net and some of Hot Chocolate, and I suspect we'll be migrating and sort of standardizing on top of one called Hot Chocolate over the long term. So my project here, it's a simple .NET Core 2 app, 2.2. It's using Postgres EF Core for getting data, which we'll get into in a minute about why that's not important. And as I said, a library called Hot Chocolate. So I'm referencing Hot Chocolate ASP.NET Core, which pulls in all the other dependencies that it cares about, and some other stuff around like entity framework and a markdown library, which we'll get into why that's useful later. So once you've added your reference to a normal ASP.NET Core app, we'll jump into our startup. And we've got 2 lines of code here that are pretty important. So this is actually like saying use GraphQL.net or use Hot Chocolate and where to set up your endpoint. So I'm saying use GraphQL HTTP post at the / GraphQL path. So this is where I want you to post my GraphQL queries. And then GraphQL HTTP schema get on / GraphQL / schema. So that's basically to set up support for this SDL call. So out of the box, like there's nothing in the spec of saying you have to have an endpoint that supports getting the SDL, but I find that it's nice to have a place where someone can actually call this and see, hey, what's the live schema of this service, which is quite useful. I use it quite a bit here at PushPay. If I want to be able to talk to a microservice, I can just go, I know I can go to / GraphQL / schema, and I can get the schema for that service and see what's going on with it. The introspection one is built in by default. Right, so we've set up our schema, or sorry, we'll set up our endpoint. Now we need to define our schema. So what we mean by this is actually defining this information. We can, how do we define these types? What types am I exposing, and what's their shapes and their behavior? So you can do this 2 different ways. Hot Chocolate, or most libraries support. The first way is called schema first. The way this works is you have a schema file. So you might have a .GraphQL or a .SDL file that looks exactly like this. This is my entire schema for this demo. And you might have a GraphQL file that looks exactly like this. And that's the definition of your schema. And then in .NET, you would probably bind some types to it. So you would create an author type that looks a lot like this. And in your schema, you would say, map this author type to this type here. And so this is referred to as being schema first. I'm writing my schema in SDL, and I'm binding to it. And if you watch most of the Node talks, or most of the GraphQL talks, this is the predominant way you'll see in demos, because it looks the easiest, and it probably is the easiest for very small demos. If you look at it like this, it's pretty easy to manage, pretty easy to reason about, right? I can see my entire schema, life is good. In about a month after that, life isn't so good. If I jump to another project, like this is the schema for one of our services here at PushPay. It just keeps going, right? And if you're managing your entire schema, I got to about a third of the way down. So it's a pretty big schema long term. If you're managing that all in one file in code, that becomes a bit of a maintenance nightmare. Like managing that, like diffing it and just dealing with changes on that file just becomes problematic. So schema first is really great for demos and for getting yourself off the ground. But personally, I find it has sort of long-term maintenance issues. The other way is something called code first. And you'll see a lot this mentioned more and more these days around GraphQL, as more companies are finding it a better way to manage their schemas. What they mean by this, and we'll just have a quick insight, is, where's a simple one to start with, is doing something like this. So I'm declaring my type in C#, right? So I'm using C# to basically do the equivalent of writing this. Why is this useful? Well, I get to use my C# types. I have IntelliSense, life is good. I can extend this and do some interesting things with C#, it's good. Other things is I can share this. If I want to have a type that is common amongst a number of services, I could put that C# declaration in an assembly and share that assembly across multiple classes. A really good example is things like paging, right? Like we've got a number of microservices here at PushPay. They all do paging, they all do sorting and so on. It would be good if we had a common contract of what paging looks like across all our microservices. So I can create my types in my schema that represent paging and put them in a place that all my services can share. Can't do that if it's schema first. I can do that when it's code first. Right. So let's dig into code first, because this one's, in my opinion, the better way. So in this demo, as I said, it's EF core talking to Postgres to get its data. So I've got my normal EF core DB context, and I've got classes like author and ID name, post ID, author ID, title. This looks like pretty much standard EF core, no objections. Sweet. That's using Node time, which is great. Always use Node time. So what I want you to think about is a really common pattern here. You'll notice up here, I've got author, post, comment, etc. Like these are my EF classes. Then I have essentially a matching type class. So for author, I have a class called author type. Author type is the declaration of the author in my schema. Make sense? We have X type, which is the definition of that type within the schema. So within hot chocolate, I'm inheriting from object type of author, because my author is going to be an object. And ultimately, if I didn't do anything else, if I deleted all of this code, it would still work, which is cool. If I spin this up, I am reasonably confident it's going to compile. And I'll query this. We get some working stuff. But there's a couple of things here. So what's kind of happened here? Internally, hot chocolate has looked at author, and it's gone, I see you've got two properties, ID and name. I suspect you're going to want to create two fields on that type, ID and name, and I'll kind of work from there, right? So if we look at this back in our schema, we have an ID of type int, a name of type string. Sweet, if that's what you want, that's cool. But I want a couple of things that are different. So this is where I can jump in and actually customize that code. I didn't want that my ID in my schema to be an integer. I wanted it to be a non-nullable ID type, so the ID scalar. So this is here where I'm saying for the ID field, for the field of ID, set its type to be a non-null ID. For the name, I want it to be a non-null string. So back to like C# 101, strings are reference types. Reference types are inherently nullable. So by default, name is a nullable string. I don't want that for my schema. I want it to be a non-null string. I want authors to always have names. So I've basically used this little bit of code here to sort of override the default sort of behavior of hot chocolate and say, no, these are the types I want. Does that make sense? Sweet. Right, so let's get into a slightly more complicated one. We'll go for the image one. This isn't much different. Again, we're kind of overriding the ID from an int to an ID and the URL to non-null string. And I don't want, like in my database, my image has a post ID, right? Foreign key reference, my images table has the post the image is for, but I don't want that post ID to show up in my schema. So I'm just saying post ID, ignore. So that says, hey, for the default behavior for finding that post ID, just get rid of it. Don't show it up on my schema. And therefore, when I go back and look at image, we don't see a post. We don't see a post ID. And let's go to a more complicated one. Actually, going back. So I mentioned this idea of resolvers. So resolver is like how you get the data for a field. Every field in GraphQL must have a resolver attached to it. Like if you think about it, like the graph is a graph of objects. Every object has fields. All those fields must have a way to get the data for that field. But we can think of these as two levels of resolver. So going back up, I've got my query class here. So this is actually the thing that goes off and gets that data. So get posts or get post. And this is basically just going to the data using the EFDB context, getting the post data, or scrolling, finding the post by ID. Nothing particularly complicated there. We go to our query type. So this is defining that top level query. I'm defining a field called get posts. Well, in this case, what I'm doing here is a lambda to a method. And this is the resolver. So what it means is you're telling Hot Chocolate, when I queried the field posts, call this method, right? So this method here is the resolver for the posts field. Hot Chocolate's actually been smart enough to know that I pointed it at a method called get posts. So chances are I want the field to be called posts. And it's done that for me. It's pretty cool, pretty handy. So when the request comes in to query posts. It calls this method, which we can see here, which goes to DB and gets those posts. Make sense? Now, posts have fields as well. And if we go back to something like the author type, again, we have the same lambda, but this is just getting the ID off that author field. So given an author, return the ID, given an author, return the name. So we can kind of think about these resolvers having two sort of classes of resolver. We can think about complex resolvers, which go off to the database and do stuff, and simple resolvers, which are like, go get the data from the field that that previous resolver already got the data from the database for. Simple resolvers, complex resolvers. Make sense? Sweet. So one thing you'll notice here is like, I could have put any code I wanted in here. In this case, I'm going to Postgres to get the database, but I could go to Cosmos DB or a flat file or anything I wanted. I could just return hard-coded data here. GraphQL is data source agnostic. So there's no reason it has to be a SQL DB, and no reason it definitely doesn't need to be GraphDB. The resolver is simply just a bit of code attached to the field to go get the data for that field. It could do anything it wanted in there. So don't worry about like what you're calling your data from. We've here at Pushpay, we've even got some resolvers which are making REST requests. So we've got a call coming in as GraphQL, and it's going off and making a REST request to get that data, pulling it back in, and then serving it back up as GraphQL to the client. So like anything can happen in here. It's quite cool. So going back again, we'll dig into resolvers some more. So one thing you'll notice here is that my get posts method is taking the blog context or my EF context as a parameter on that resolver, which is kind of weird, right? Normally we think about like these things as dependencies as being constructor injected, right? But our DB context, and if we wanted to, we could put our dependencies up here in the constructor, and Hot Chocolate will happily inject them in there. But this query class only gets created once. It's essentially singleton to a certain extent. And what that means is by default, we kind of want our EF contexts to be per request or a scoped dependency if you've been playing around with .NET Core. And therefore, we want a new one per web request. We don't want to share our DB contexts web requests because that way lies pain, lots of pain. So what Hot Chocolate supports this notion of is creating dependencies at the resolver level and sort of marking them up here with service. And Hot Chocolate will use the scope dependency injected in there. So I'm getting sort of a per request dependency. And I can mix and match. I can have some of my dependencies up here being singleton and some of my dependencies down here being sort of per request. Does that make sense so far? Cool. All right, let's go into some of the more complicated things we can do. So this is my post type. Again, my post type is representing a post, so it's inheriting from object type of post. I'm doing the same things around making sure my ID is nullable IDs. I'm getting rid of the author ID field because I don't care about it anymore on this. I'm making my strings nullable. And the interesting thing is here, like in the database, I haven't shown it, but on my post, I only store the markdown for this post. But if I want to support the things I want in my API, I want to serve up the HTML. So I've created a new field called HTML. I've said it's a string, and it's sort of attached the resolver to it. So this is the method to call when someone requests the HTML. And all it does is gets the parent post, gets the markdown off it, and turns it into HTML. So what I mean by parent here is, there's a notion of graph. So when we go back to our graph here, this HTML field, the parent field, that field is post. So we can actually get the data from that post field and then access it down here in these fields. So get the parent post's markdown, commit it to HTML. So you can think of this essentially as now being a computed field within GraphQL. It's not a field which exists in my data source, but I can still expose it and go from there. And again, this is a really good description or demonstration of that field resolver thing. I'm creating a field called HTML, and I'm attaching a chunk of code to it to get that data, attaching a resolver to it. Now we get into some more complicated ones where I'm actually going about doing the building a bit of a graph. So we'll look at the image one. Yeah, an image. So I'm creating a new field. I'm calling it image. I'm declaring that this image takes an argument called size, and that size is of the image size type. So again, we've got an enum. We've got an enum here called image size, and then we have a matching because we always have an X type match that. We have an image size type, which just inherits a enum type from image size, and that's what gives us our SDL. Gives us this. So the SDL supports this notion of enums out of the box. And going back to our post type, Again, argument of type size, argument of name size, takes an image size. It's not nullable, and default value is small. And then we're attaching the resolver to it is this method up here. Again, this is going back to the database and getting the images. The first image, which is of the appropriate size. Right, so we've attached a bit of code, and now we've got a graph, and this graph is returning an image type, so type image. So this is where we go back and we can see in our SDL, here's our post. Our post is an image field, takes a size argument of image size, the default is small, and it returns an image. Makes sense? We're kind of lining them all up. And again, same thing, we're doing it with comments as well. So there's a method called resolve comments, creating a field called comments, and its type is a list type of comments. And same thing, in this case, we're doing some interesting things. We are doing our service injections. We're injecting that DB context in here, and we're also asking for Hot Chocolate to inject the parent post. So instead of saying I want, I'm going up to a markdown, instead of going context.parent, I can actually tell Hot Chocolate, say, just give me the parent post, and I can go from there and use its post ID and find the appropriate comments for it. Cool. So let's just quickly jump to mutations. I'm creating, so if you think about it this way, where are we here? I've got a class here which isn't actually related to EF core. It's just like an object that represents the data. So submit, post, input, author ID, title, markdown. And same thing. This inherits from input object types. So input objects are separate from output objects because they have different things you like to do with them in the spec. But the behavior looks much the same. I'm configuring fields with author ID, setting their type, setting their title, and so on. I have a mutation class. It's in this case, it's dependency injecting in the clock, service injecting in the DB context, and taking my submit post input as an argument on that resolver, creates a new post, adds it to the database. So if you look at our mutation type, I'm declaring a field mutation. So it's a mutation type, and here it's object type mutation. Submit post, it returns a post. It takes an argument of input of type submit post input type. And what's really cool here is Hot Chocolate's doing the work to take that JSON post from this down here, turn it into that object, and inject it into my resolver for me. So I'm just taking that strongly typed input in my resolver, which I've declared as an argument, and I can do my work for it. So Hot Chocolate's doing all that work for me, basically building up that object, validating it, passing it to me, and I can kind of work with it, knowing that it's as per the spec. Does that make sense? Sweet. So this is all the types that define our schema. We've defined a whole lot of types. It definitely looks like a lot more code, right? Like if I said, hey, I want you to write all these types, or your other way is to just write this file. Writing this file feels a lot simpler. And it is. It's the best way to demo some of this stuff, and it's the best way to get off the ground. But long term, when this file becomes many thousands of lines long, it stops becoming easy to manage. And when you build your types using things like this, you have your full power of Visual Studio and ReSharper and IntelliSense and source control to help you manage these things a bit easier. Again, sharing these types across multiple services becomes a lot easier when they're in here as well. And that's not to say that this is a black or white decision. You can do both. You can actually pull in part of your schema from an SDL file and then bundle some more types that have been defined in C# on top of that. And some of our teams here at PushPay, we've left the decision for each team in PushPay to kind of do it the way they want. So we've got some teams which are doing schema first and some teams which are doing code first, and some which are doing a mix of the above. So it's really kind of a sort of a subjective decision, but this is the way I kind of prefer. So we've got all these types, right? We've got our query types defining our top level fields. We've got our other types declaring what those fields can do and sort of extending them and so on. Like, how do we actually set them up and use them? So going back to our startup, in our configuration at the top here, we're doing our normal things. I'm setting up entity framework in the blog context. This is the interesting part. So I'm saying add GraphQL, and I'm building my schema. So I'm saying creating a new schema. I'm setting the query type. So what's the root? What's the root thing that all my queries are going to? And I'm pointing it at that query type I've created. Set the root, the mutation type to be mutation type. And we'll come back to that one later on. But you notice, like, I haven't specified many of the other types, right? I haven't told it about post. I haven't told it about image or anything like that. And there's no reason I need to, because query type references posts. Posts reference authors and images and so on. So ultimately, Hot Chocolate's going to discover all those other types that I've declared just through navigating this one. So the sheer fact of just pointing it to, to these two is enough to build the entire schema. So this creates my schema, gives it to Hot Chocolate. That schema is already pointing at the resolvers. So this defines the shape of our schema, as well as saying like where to go to get that data. And we're done. That's it. We've built our GraphQL schema, our GraphQL service. We can happily sort of submit, post to that, and get our data. That makes sense? Sweet. All right, let's move on to some other stuff. Get some advanced features. So I said at the start that GraphQL has scalars like integer, boolean, ID, string, and so on. You can make your own ones on top of that. If you want to support some sort of more stuff that's strong in a strongly typed fashion, you can create your own ones. So a common one we've used here at PushPay is instant, right? We want to support the notion of a timestamp of when something has happened. We love using notatime. So exposing something as an instant in our GraphQL schemas is really important. So I can say scalar instant, and then I can use it just like I would like boolean or string within GraphQL. In this case, I have an event, and it occurred on, and I can provide that instant that it occurred on. The next thing is this notion of interfaces. So GraphQL supports this notion of an interface. If you're a .NET developer, you think you might already know what an interface is, right? It's a contract between classes, and the idea is you would program up against the interfaces instead of the class, right? That's what we do with interfaces. It's a little bit the same. You get the same sort of semantics at the server end, but how you use them in the client is quite different. So in this case, I've declared an interface called event, and it has a field called occurred on. I've then got a type called product reviewed event, and it implements event. And again, so if I tried to take away that occurred on field from product reviewed event, this would be an invalid schema, and my service would fail to start. And then I've got another field here called review on that because that's the notion of the data that's specific to that event. Make sense? We'll get into how that's used in a minute. And another sort of example of this is what are called union types in GraphQL. So up the top here, I've got a type called checkout failure. Ooh, shouldn't try and double click stuff. There we go. Checkout failure. So imagine checking out a shopping cart, and it returns validation errors. I've got another type called checkout success, and it returns the order. Right. I've created a union type called checkout result, which is going to be either a checkout success. I typoed that. It should be a checkout success or a checkout failure. My bad. That last part should be checkout failure. So what that means is that when I say a field is of type checkout result, it means that it can return a success or it can return a failure. It can't return neither, and it can't return both. So it's a little bit different from an interface. An interface could return a couple of different things. The result means it's going to be this or it's going to be that. It can't be either. So how we support that in the actual query is really interesting. So imagine if we have a field called latest events. And latest events returned a list of events. Events is that interface I described, right? So I can query for the occurred on without any sort of interesting things because occurred on is a field on that interface. But I might want to say, well, actually, when it is a product reviewed event, I want to get some more data. In this case, so what this is, what that dot 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 is called a fragment. So dot 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 on product reviewed event, get me the review data as well. If you imagine that my interface had 50 different sort of implementations of that interface within the schema, you might have a number of these dot dot dots, which might be get me the occurred on events. If it's a product reviewed event, get me these things. If it's a product added event, get me these things. If it's something else, get me those things. So this is kind of a little bit different than the way you think about interfaces in C#. You know, we build user interfaces in C# for hiding away the implementation. Here we kind of care about the implementation. We care about like, hey, when it's this type, do this thing. When it's this other type, do this other thing. And the same thing is for those union types. So if we imagine this was a checkout field, a checkout mutation. So I'm doing a mutation, check out my shopping cart. Or we might do something like dot 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 on checkout successful, query these order details. Dot 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 on checkout failure, get me the validation errors. And a reason why we might want to do this, if I go back, one thing I didn't show was on every type, we can always query the type name. So if I send this, oh, sorry, I stopped the server. Cool. If I send that, thank you. Cool. So come back, type name post, right? So if we go back to this, if I query dot dot type name under latest events, then it would give me back type name product reviewed event. So that means my front end code can actually do some interesting things. It can actually know the type information of those events on the way back. This is cool because we now have types on the front end with things like TypeScript. So what can happen, you go the whole shebang down this way, is you have that SDL. You're exposed, you have a strongly typed schema that represents your GraphQL. You can then type gen TypeScript based off that SDL. That gives you strongly typed on your front end. And so what that means is if you query for latest events on the front end and it's querying for type name, it can then correctly construct the appropriate product reviewed event type in your JavaScript. And therefore TypeScript can help you at that end as well. So you can say, if my event is a product reviewed event within your TypeScript, it's really useful. What was here? So GraphQL also supports this idea of what they call directives. What example I've used here is called deprecated. So this is one that's actually built into the spec. And you can think of these as much the same way we think about C# attributes, which is essentially like a piece of metadata on a type information, which doesn't actually do anything out of the box. You have to have another piece of code go and act upon that whether that attribute exists or not. But they're useful for marking up metadata within your schema. So in this case, I've said, hey, I've got a person, they had an email field, and now I want to support this notion of the fact that they have multiple emails. So I've marked it as being deprecated, and I can do some information about when that thing is deprecated or not. Another example of this is something that comes out of the box in hot chocolate. So hot chocolate has built into it. So this isn't part of the spec, but sort of an extension via hot chocolate, but still part of the spec in the sense that custom directives are supported within the GraphQL spec. So you can do whatever you want. One that a custom one that's out of the box in Hot Chocolate is authorize. So I can say I have a moderation queue of comments in this case, and I'm saying authorize only people who follow the policy content editor can actually request this field. So if you've done any MVC, you'll remember the notion of putting an authorize attribute on your either your controller or your actions to say these are the roles that can access this, or this is the ASP.NET Core policy that must be fulfilled in order to access that. This works the exact same way, right? So Hot Chocolate's going to look at that, look at the incoming request, check to see if you're logged in, do you meet this content editor policy? If not, kick you back out, don't return the data, right? So this is how custom directives work. And you can build your own. We've got a whole bunch of our own custom ones, which we use to do things like expose validation rules to the client or enforce other bits and pieces. So you can totally build your own within Hot Chocolate or within your own library and do whatever you want with them, really. Data loaders. So if you've been paying attention, you might have thought, oh my God, this contains n+1. And in fact, the implementation of parts of the demo I showed you right now contain a problem that's exactly like this. So hands up who've used an ORM like EF Core or any ORM before. So who knows what the select n+1 problem is? Cool, sweet. So I'll describe that really quickly. Notice how most most ORMs have the concept of lazy loading, right? So if I pulled down my post object out of EF Core, I went .author.name. As I hit that .author, it's going to go off to the database and get the author object, and then let me put the name out, right? Make sense? Everyone's seen that before? Knows what I'm talking about? But what would happen if I did a query which pulled down 100 posts? Then I looked over those posts and printed out the author's name. That's going to result in 101 database queries. All right, we go pull out 100 and assuming, that all posts had a unique author. But you can imagine, first database query gets 100 posts, go off, get author 1, go off, get author 2, go off, get author 3. Bad things happen. That's what's referred to as the select n+1 problem, because the way we've written our code means we end up with 101 database queries. And we can have much the same problem in GraphQL. So going back to my demo, if you imagine this code actually is a perfect example of this. So my top level field posts is going to the database and getting all the posts. So it's going to hit, stop this. It's going to hit this method, which goes off and gets all the posts I need for my database that I care about. Then I have this image field, which queries, where did I put that? On post type. Where's resolve image? This, which hits this, which goes off the database and gets the image for that post. Make sense? But this one will be hit once. This one will be hit n times, whereas n is the amount of posts I returned. That's not cool, right? I'm going to end up with like 51 database queries. Yuck. I'm pretty sure my SRE team is really going to hate me if I end up rolling this in production, right? We're going to have a whole lot of database queries. So what can we do about this? We can use a tool called a data loader. And I've got an example here for this. So I fixed up my author call, which does the same thing, right? Author goes to the database to get the author. It has much the same problem. If I was querying author of posts, then I'd result in lots of author calls. So I create a data loader. And I won't go too much into details about this, but basically give it a unique name and pass it a Lambda. And this Lambda assumes I will be given a list of author IDs, and it expects me to return a dictionary of author ID to author. And essentially what this does is batches this up. So this query here, where I'm getting 100 posts back, instead of calling, it'll call this method here 100 times, but it'll only call this internal method once with 100 author IDs. So it essentially allows me to batch that back up into a single database call, and means that I won't do horrible things to my database and my SRE team. But that's data loaders and an N+1 problem. The last thing is something called schema stitching, which is really cool. So we've got a number of microservices here at PushPay. Each of them expose GraphQL query, GraphQL services. What we want to do sometimes is build a GraphQL schema which represents a collection or a union of those two schemas. So we want to take some information from this schema and take some information from this schema and combine them in some way. So we can think of the stitch schema, the thing at the top there, almost like an API gateway. So we have our API gateway and our application here. Our application up here is using GraphQL. This thing here is then sort of parsing that GraphQL, working out what GraphQL identity covers, pulls back that data, combines them. These things under here don't even GraphQL. We can actually imagine this could be REST, GraphQL, and remember these things solvers. Unified GraphQL schema with providing your application, adding the links to the application. And in Hot Chocolate, it looks something like this. So I'm saying from my customer microservice customer, and I'm adding a field onto that orders, and again, custom records is what you say from the orders microservice, and this is how you go about getting the orders for a customer. Go to the orders field on the orders service, ask the customer ID, customer. So this means in my unified graph up here, the application can say, get me the currently logged in user, get me their first name, and get me their orders. And what would happen here is that go to the customer service, get their name, orders service, get their orders, and it can actually handle doing stuff like going here, get customer information, using the results of that field, change the query that goes to orders as well, so you can do it that way. That's really cool. So the link for Hot Chocolate is as follows. Just to basically search for it. I can't remember what the website is. The demo for all of this is there. I'll post these slides later on to the meetup as well, so you can always just go back and get these links. Questions? I think it's perfectly timed since I can smell pizza. Okay, it's cool. So the question is, how do you do versioning of the API in GraphQL? The stock standard answer you'll get from most people is you don't. This is the fun part, right? So if I go back to this, we can think about it in a couple of different ways. Remember that people are only querying for the fields they care about. So you need to worry about, like, you can make widening changes to the API really easily. If I want to add another field to person, I can very safely. Like, let's say I'm adding a age field to this person. I know no one is querying for age right now because that field didn't exist before, right? So I know no one's querying for it. I can be really safe adding it, and I'm not going to be changing anybody's current results. I'm doing something like REST. If I add the age to person, everyone's going to get age right as soon as I deploy that to production. And if someone's doing something really dumb, they might break on that result change. But I know that because no one's asking for age, I'm not changing anyone's results in production until they start asking for age. So that means that widening changes to your schema are sort of inherently safe. Narrowing changes, like removing a field, isn't safe, right? Or changing the type. Like you can make something go from non-nullable to nullable safely. Can't do it the other way, right? It's a narrowing change to the schema. So you can do this a couple of different ways. This is the way I kind of recommend. Like or I think about, and it sort of starts with communication, right? Like, let's say, again, going back to the scenario, my person used to have an email field. I wanted to have an emails field, and therefore I want to get rid of the email field long term. I start with doing this, right? I can start to say, I mark it as deprecated and say, hey, you should use the emails field. That means that anyone who's now consuming that API should hopefully see this deprecation notice and use the correct one. I then do my normal thing. I should still do comms out to my clients and say, hey, this is the thing you want to be able to use. You can actually do documentation that generates off this. So your API documentation automatically updates to say, hey, this field is deprecated. And you would do your normal API advisories as is. The really useful thing is I can monitor the usage of my email field. So in a month's time, I can say something along the lines of like, query my local logs or metrics and say, how many people are still using email as opposed to using emails? And if it's none, then I can remove it, knowing that I'm not going to break anybody's experience. Everyone's already migrated across. And because it's GraphQL, I can measure on the server how that migration is going. And if there's maybe one customer that's still a holdout, they haven't moved across to using email, then I can call them up on the phone and say, like, hey, get it together. Or something along those lines, maybe a little politer than that. One thing I saw that was really cool from GitHub, so GitHub actually built support a GraphQL API. They built this into their tooling. So if someone creates a pull request that makes a breaking change to a schema, so let's say I created a pull request that removed that email field, they'll have a bot that looks up their metrics and comments on the PR saying, hey, you've removed that email field. That was used 100 times by 20 different clients in the last month. And you can actually look that up because as long as you're recording the metrics about the field usage, right? So the notion of sort of versioning in GraphQL is the default answer is don't, in the sense that you can make widening changes very safely. Narrowing changes are always inherently unsafe, but you have some better tools to manage like how that migration might go around removing and measuring the usage of things that you want to remove from your system. Make sense? Any other questions? Cool. So the question was how do you do security on this? So the ones we've been doing here have been using JWT bearer tokens for authentication. So the user's going to some other system to get their bearer token, through an OAuth 2 process. Then they're sending that token up to our system. And from there, it can go basically into the normal ASP.NET Core authority and identity stuff that essentially Rory's going to be talking about. In the sense that the person has an identity, and then you can go into like, hey, what roles do they have, and you can start to lock that down in the sense that, like, right here I'm using Hot Chocolate's authorized directive to say they must meet this policy, but instead of policy I could do roles to say you must be in this role to access this field. And in if you're querying a field that you don't have access to, then Hot Chocolate will spit out like an error at that point. Yeah, it's not so security is not part of the GraphQL spec whatsoever. It's up to like individual libraries to work out how they want to do it. And this is the way Hot Chocolate does it, which kind of lines up much the sort of way the mental model you think about when you're doing sort of MVC and so on. We'll quickly jump in one just before we get to pizza. One of the things that's kind of interesting here is Hot Chocolate will support this notion of sort of partial responses. So imagine that in this query, you weren't allowed to, actually, none of that one. Sorry, let's go back to this one. Imagine that the author field was behind some role, right? And you weren't making a request and you weren't in that role. What Hot Chocolate will do is return you the data that you do have access to, but author will know. You don't have access to that data. I'll give you the rest of the data you care about. You don't have access to it. And there'll be above that errors collection, which says, hey, for hot data posts author, you don't have. You'll spit back an error, but you'll still get the data for the rest. Make sense? Sweet. Good time for pizza. Thank you, everybody.